The last style of calculation that we're going to do in this chapter is to calculate the amount of excess reactant that remains at the end of the reaction. Remember that the excess reactant isn't all used up. The limiting reactant is. It does imply that some of it will be remaining at the end. We just need to be able to quantify it. We need to find what's left over. So let's resume our lovely limiting reactant calculation that we had started before. Everything is the same. We still have the answers to our two previous stoichiometry problems, and most importantly, we've provided ourselves with some labels. We know what our theoretical yield of product is going to be, we know what our limiting reactant is, and we know what our excess reactant is. Well, if my excess reactant is sodium, I'm provided with 25 grams of it. But that doesn't mean that I use that much. I want to know how much of it I have left over at the end. What I do know is I use up all 25 grams of my Cl2. Now remember, stoichiometry can relate any two chemicals to each other as long as you have a balanced chemical equation. A lot of the stoichiometry that we do tends to go from reactant to product, but it's perfectly legal to have a calculation that goes from reactant to reactant, in which case, if you have one reactant that you're relating to another, it'll tell you how much of it that you've in fact used. So again, all problems from here forward are going to spring forward from this 25 grams of Cl2. So time to start another cute little stoichiometry problem. And here's our add-on to this problem and what this would actually look like. How much excess reactant is left over at the end? Again, that means that we're going to be starting from our 25 grams of Cl2. It's going to give me a correct answer. And I'm going to calculate over 2 grams of Na. I'm given 25 grams, but that doesn't mean that's how much that I've used. Another way of visualizing this is once you've identified your limiting reactant, you want to do another stoichiometry problem that ends up with the grams of Na in the top last box, your excess reactant. So we can almost copy down half of the previous stoichiometry problem that we did, starting with our limiting reactant, our 25 grams of Cl, and convert it into moles. And again, the moles of Cl can drip down to the bottom. What I want to replace it with this time, however, is moles of Na. And don't forget where those numbers are coming from. Those are numbers in front of the coefficients from the balanced chemical equation. All I have left to do is to convert that back into grams, exchanging 1 mole of Na for 22.9899 grams. And let's solve. So again, we took our limiting reactant and we calculated to grams excess reactant. I find out that I've only used 16.2 grams of Na. Well, that's lovely, but I still need to know what's left over. One extra small calculation left to go. If I want to know what I have left over, I have to take what I was given, subtract out what I used, and that should equal our leftovers. In this case, what I was given was 25 grams of Na. I used 16.2 grams of Na. That leaves me with 8.8 grams at the end of the reaction. So one more time, if I want to calculate the amount of excess that's left over at the end, I first have to calculate how much I've used. You do another stoichiometry problem. You start with the grams of the limiting reactant, and you calculate to grams of the excess reactant. That tells you how much you've used. You subtract it from what was given, and that gives you your leftovers.